Hi class, this is lecture 28. What we're going to do today is to figure out, based on the cost of capital, what is the value of the firm. Now to wrap up what we did in the prior slides, we first need to figure out what is the end weighted average cost of capital under each scenario. So we've estimated the cost of equity, and here we've now estimated the pre-tax cost of debt. It was based on the interest coverage ratio for different debt ratios. That gives us the bond rating under different scenarios, right, based on our prior tables. And that's then going to give us the pre-tax cost of debt. It's going to be fairly low initially, right, as we have a AAA bond. It's going to slowly increase as the bond rating increases, and then it'll get quite high as we get to these CC and C bonds. What I want to point to is that the tax rate is essentially constant up until 60%, right? So we're just going to take the pre-tax cost of debt, multiply by 1 minus the tax rate, get the after-tax cost of debt. That's not going to be true for these very high debt levels. So what's going on here? Why is the debt level changing? Well, the problem is that you only get a maximum tax benefit of interest expenses, right? And that really depends on your income. So let's take Disney as an example. Disney had an EBIT of about 10,000 million or $10 billion. As long as the interest expenses are less than this 10 billion, interest expenses remain fully tax deductible and earn the full 36.1% benefit. So at a 60% debt ratio, the interest expenses are 9.5 billion, the tax rate is therefore 36.1. Once you move to 70% debt ratio, the interest expenses balloon to $11 billion, and that's greater than the EBIT of 10 billion. So the tax benefit's actually going to be smaller. How much smaller we can actually figure out. The maximum tax benefit is 10 billion multiplied by 3.61, right? The 36.1% tax benefit. So the maximum tax benefit is going to be $3.6 billion. So we take the 3.6 billion, divide by interest expense, which we got from here, and that gives us the adjusted marginal tax rate is 32.6%. Okay? So essentially what it's saying is that we actually have a slightly lower tax benefit, right? Because we're only able to get a maximum benefit of $3.6 billion. So 3.6, the maximum, divided by our actual expenses, give us a tax benefit of 32.64%. And that's how we get this number here. If we do this again, we're going to get, here we even have a higher debt level, right? Interest expense went from 11 billion to 13.5. We do the same calculation, so take the maximum tax benefit, right, divide by interest expense, and that gives us an effective tax benefit of 26.8. Do it a third time, we get an even lower number. The effective tax benefit is 22%. So here we're going to multiply the pre-tax cost of debt times these alternative numbers, 1 minus these numbers, to get different after-tax benefits. The reason is because we multiply the pre-tax cost of debt times the tax rate because there's a tax benefit of debt. Now, generally, the tax benefit is just the total tax amount. But at these very high levels, that no longer ceases to be the case. And so because of that, we actually need to multiply by these kind of adjusted tax benefits. Once we do that, we're then able to figure out the adjusted marginal tax rate for each tax, figure out the after-tax cost of debt. And so we find a tax of debt of 2.2% when debt ratios are 0 to 20, and it increases over 10% when debt ratios become 90%. So we finally now have all the information we need to figure out the weighted average cost of capital. We have the debt ratio of different levels from 0 to 90, the betas, which we saw increase as we increase debt, resulting in increased cost of equity. And now we have the after-tax cost of debt, right? And as we saw, these numbers are actually even slightly higher because we don't get the full tax benefits of debt. When we take the weights, right, we're weighting cost of equity and cost of debt by the debt ratios, we're given a weighted average cost of capital of 8.07 to 13.84 here. As you see, when we start, we decrease the weighted average cost of capital to 7.16%, and then we start increasing again. Based on our argument, this is the lowest weighted average cost of capital, which means 40% is the optimal debt ratio. And here's a graph of what we're thinking of. The purple line is the weighted average cost of capital. We see that it decreases slowly to 40% and then starts increasing pretty quickly. And that's because, as we saw, we're increasing both the cost of equity and cost of debt as we increase leverage. We're also putting more weight on the cheaper option, the debt. We can actually see that in these red and green lines. And what we see is that debt, the cost of equity does increase, but it increases very quickly once you kind of hit, 50, 60%. The cost of debt stays very low until we hit 50%. So it's not surprising that right here, right, when the cost of debt still remains low, that's our optimal level. Because once we go from 40 to 50, the cost of debt actually increases pretty substantially. So this suggests that the optimal debt ratio for Disney is 40%. And that would give you a debt level of $55.1 billion. Their current debt is actually 15.96, so it's substantially less. So according to our calculations, they're under-levered, right? They have excess debt capacity of 39 billion, meaning that in order for them to reach their optimal level, they should take on an additional $39 billion in debt. Now, how should they do that? Well, what it actually means is they would borrow money in $39.14 billion, and then they'll use this money to buy back stock. And that will both increase their debt and then decrease their equity. So they get back to their 40% debt ratio. Now, given this magnitude of this decision, we have three different questions. First is, why would we do this? We want to estimate what is the dollar value of making this change. The second that we'll answer is what if something goes wrong? And the third, what if we won't or cannot buy back stock and want to make this investment with the additional debt capacity? In this lecture, we're only going to answer the first question. So why should we do it? We want to figure out what is the increase in firm value due to changing the debt level. And we're going to do it under two different methods, and they're actually going to give us different numbers. So the first method, I'm going to call the full valuation method. Because what I'm doing is I'm going to figure out the full value based on a net present value calculation, right? So I'm going to estimate the free cash flow to the firm at time 0 multiplied by 1 plus G, and then divided by R minus G. Now, in order to do this, we need a couple different things to estimate, right? First, we're going to need to know what is the free cash flow to the firm. That's just based on our prior calculations, 3,657. The second thing we're going to need to know is what is the growth rate. And the growth rate we've estimated, right, as the implied growth rate here. So I'm going to figure out what is the growth rate, which is 4.94%. The way I'm getting this is I'm actually kind of backing at the growth rate out based on the current value of the firm. If the current enterprise value of the firm, so equity plus debt minus cash, is 133,908, we're going to set this equal to the current free cash flow divided by the current cost of capital, which we know, right? The current cost of capital is 7.81, and then we're going to solve for G. And if we solve for G, we're going to get this number. I'm going to assume this G stays the constant, because as I've said before, we're always assuming here the only thing we're changing is the cost of capital, not the cash flows, right? If we're not changing the cash flows, then the growth has to stay the same. So we're going to take the free cash flow that we had before, multiply by 1 plus G to get the free cash flows in 1 year, and then divide by the cost of capital minus G. Now the cost of capital here, 7.16, is this cost of capital, right? The cost of capital that was lowest, which was when the debt ratio was 40%. Plugging this number in, we're going to give a new firm value of 172,935 million. The difference between these is 39,000 million or $39 billion, right? And that's just comparing the new value compared to the old value. Here's an alternative approach. I'm going to call it the incremental approach. And in this approach, what we're going to do is we're going to start with the current market value and isolate the effect of changing the capital structure on the cash flows. So let's walk through this two in pieces. First, what is the enterprise value before the change? As we estimated before, 134,908. What is the cost of financing at the existing debt ratio? Well, we're going to take this value and we're going to multiply it by the current cost of capital, right? And so what this says is that this is how much we're spending in a given year, right? Because for every dollar of value, we're spending, right, 7.8 cents in cost of capital. So if we have this amount of dollars in total in, right, at the firm, this is the amount that we're spending each year. Then we can compare the cost of capital of financing Disney at the optimal debt ratio, which is 7.16%, right? This is the optimal, which is the lowest that we found at 40% debt. That gives us a cost of financing here. So the annual savings is right here, right? $866 million we're saving annually, according to our calculations. We're going to, again, plug this into a perpetuity. We're going to assume that we get this money next year, and in perpetuity, and it's going to grow at 2.75%, the long-term growth rate. Divided by the new cost of capital, that would increase the value of the firm by $19,623. The enterprise value then after capitalization is going to be the existing enterprise value plus the present value of the savings, right? How much are we saving that we didn't have before? So we're going to find that the new value is 153. Now, that number is actually different from what we found here. And it really depends on what exactly our assumptions are, right? Because our assumptions depended on kind of what the growth is, right? In terms of currently, and if this growth is going to hold. Here, we're actually going to make a different assumption about the growth. So depending on kind of what assumptions you're making exactly, these increases in value are actually going to be different, and therefore the firm value is going to be different. It's not necessarily the case that one of these is better or worse, although I would probably argue that the full valuation is probably the better way to go. However, they're just different methods depending on what your assumptions are. And so every time you change the assumption, you're going to change what is the full value, the actual value. So let's move to a question. CIMAC Inc. is a publicly traded company and its current cost of capital is 9%. You have computed the optimal debt ratio for the firm to be 40%, and the cost of capital at optimal is 8%. If the firm is mature, with the expected cash flows growing 2% a year in perpetuity, how much will CIMAC's firm value increase by on a percentage basis if it moves to its optimal? Now, the one thing we're missing here is we're missing the cost of, we're missing the cash flow. There's no cash flows anywhere here, as you can see. And if we don't have the cash flow, how are we going to plug it in and figure out the value of the firm? What I want you to note is that we're estimating the firm values increase on a percentage base. So it's not important what the cash flows are because they're not changing, right? And if they're not changing, we can plug in anything. And I'll show you this by just assuming that the cash flows next year are $1. So the value at the current cost of capital is going to be $1 next year divided by R minus G. The old R is 9% and the G is 2%, because that's also not changing because we're not changing the cash flows. So 1 divided by 0.09 minus 0.02 is 14.29. Instead, the value at the optimal level is going to change the 0.09 cost of capital to 0.08. And under that alternative model, we're going to find out that the value of the optimal is 16.67. We're then just going to estimate the difference. And estimating the difference is going to say that the percentage change in value is 16.67%. Now, the reason we don't need to worry about what the cash flow is because since we're taking the relative difference between these two values, the cash flows are going to cancel out because they're the same, right? The cash flows aren't changing. So if we divide one by another, it doesn't matter what that number is. So turning to the answer again, the value of the current cost of capital is 1 divided by the old R minus G. The value of the optimal is again the same 1 in cash flow divided by the new R minus G. Taking the percentage increase, subtracting off 1, gives an increase of 16.67%. This concludes lecture 28.